So here we are with our new setup. This is the power supply, 24 volt. Actually it is 100-watt power supply, and this is ESP32, which is 30 pin board, but there are 38 pins, which is more typical. This is the latest 30 pin board with type C connector. These are some robotic wires, breadboard wires, I mean. Apart from that, this is the driver for this stepper motor. This is one of the best and finest driver available in the market, and it is called LV8729. This driver has one of the most finest movement available in the market, and it is also having some smart features as well for managing heat and like microstepping management. Everything can be automated as well. Apart from that, this is the Nema17 stepper motor. Okay, let's see how our controller looks. This is the controller that you see, the controller page. What I mean is that this will be controlling the stepper motor via this driver using this controller. This controller is storing this web page that you see, which is coming via the Wi-Fi, and this is the code that I have written. Let me show you. These are the code. Okay, this is the web page, and these are the code, so which is stored inside this microcontroller, and this is the web page we'll be using to control. So let's turn on the motor and see how it performs. Most probably this rotor should give a shock when I click on enable button, so let's do it. Did you saw it had a shock? And let's start it at default speed with full steps. It will make noise because of full step. I think you can listen, the noise is made by the motor. Okay, it's because it is in the full step. Let's increase the speed. We can increase the speed as much as we want, but we need to be in a particular rhythm. When the motor is already in a particular speed, we should only then increase the speed ahead. Otherwise it will be just vibrating. Slowly the speed should be increased. Okay, this is the full step part. Let's go to the micro steppings. These are the micro steppings supported by this little tiny driver that you see. By the way, the blue color is the heatsink, but the driver is right below it. So these are the micro steps. From full step to 1 by 128 steps of micro steps is available, which means each step will be divided by 128 micro steps, which is really fantastic. So we have already seen how full step is performing. Let's see how other options are performing. This is 1 by 116. Okay, let's increase the speed, and if I go to like a little bit more less micro step, it will increase the speed at the same pulse. Let's make it 1 by 4, this much fast, and most probably if I go to 1 by 2, then it might vibrate. See, is because it has not reached the speed and it's suddenly having the pulses really fast. Okay, and let's check out the most important part of this driver, that is 1 by 128. In 128 the movement is so fine, so precise, and the motor feels like dead because it is not making any noise. So fine movement. And if I want to make it even slower, it will move with very fine movement. I hope you can notice it's moving very slow, and you can go as slow as you want with this kind of micro stepping. This is actually made for that fine movement. I hope you can notice the movement because it is too slow. I am controlling it right from here. Okay, if I increase the speed will be faster or slower from this. Okay, like this. So I think that's it for this video. Here we were just looking after this new driver that I came up with, so you will get to know about why I'm making this setup in further videos. So there is a surprise that you guys will get to know, which I haven't shared yet with you guys. So hit the subscribe button so that you can find out what is that surprise is about. See you in another video.